So today we're going to talk about throwing try-catch in the bin and leveling up our error handling with the result type. So who am I? Despite my introduction already, I am Dillon Mulroy. I am a software engineer. I have 11 years of experience mostly working in this kind of ecosystem. I currently lead Vercel's domains product area and engineering team. And as Ken said, I care deeply about building reliable and scalable software, both on a technical basis and organizational basis. You can find me yapping pretty regularly on x.com, the Everything app, streaming Monday through Fridays in the mornings on Twitch, and some of my open source and work on GitHub. So just to run through the agenda quick, I'm going to give a brief aside. We're going to talk about the problem with TypeScript, the power of an error, the result type itself, a quick practical guide to adopting the result type with React, and a summary and wrap up for takeaways. So, a brief aside. This talk was originally going to be about the what and how of using the result type with React. I was going to get real in the weeds with building an intuition of how to implement the result type and go deep on code samples of how to integrate with the use hook and all the new server actions and all that stuff. But over the past couple months, I kind of took a step back and thought about what I really wanted to convey and deliver through this talk. So instead of talking about the what and how super deeply, we're going to focus on the why. My first React conference was a decade ago now in Salt Lake City at React Rally. Is anyone there? Yeah, we're dating ourselves. And reflecting on 10 years of being at React conferences, the talks that have stuck with me most haven't been talks about the latest state management library or data fetching solution. They were talks about an idea or something that might inspire curiosity to go back and try to make my code better. So that's my goal today. On top of that, watching what React has grown into, now growing into essentially a full stack solution. React devs are becoming more and more of we are full stack devs now. We have more complexity on the server. We have, to deal with distributed system problems, more business logic, and it just necessitates more care about how we build our software. Couple that with the fact that we are now very quickly integrating AI into our applications, product, and software, which is inherently non-deterministic. We need ways to reliably deal with that non-determinism. So I felt it was important to really get across why we need to care more deeply about how we handle errors in React. And don't worry, this is still going to have React in it, and it's going to be geared around React. So, the problem with TypeScript. Only one? Just kidding, but only kind of. So, some of you may have seen me use this same slide in other talks, but I think it is truly important to set the scene. My hot take is that JavaScript has the lowest bar of entry to building and being productive, which is a good thing, right? It enables so many people to get into our industry, into our field, start vibe coding, whatever it is. But on the other hand, it also has one of the highest bars of any language and stack to building high quality, stable, and reliable software. I go on to say the biggest problem with TypeScript and Node is that the language makes it far too easy to only ever consider the happy path. I want to focus in on that, the happy path. And I want to talk about something I like to refer to as happy path blindness. So let's use an example, right? Let's say my customer support engineering team comes to me and says, hey, Dillon, we need a tool in our admin back office to get information about our customers' domains. So I go and I whip up this code sample. And I know every single person in this room has dozens, if not hundreds, of functions that look exactly like this in your code base. But it is deceptively unsafe. So what happens if auth.check throws? Does it throw? Can it throw more than one kind of error? We would have to dive into the implementation to find out. What about db query domain? Does that throw? We have no idea. can we retry on any of these errors if they do occur? Do we have to consider, exponential backoffs or global rate limits or thundering herd problems? As I just said, should have just followed my slide here. And most importantly, how do we communicate errors to callers? Should we pass through the errors, all of them? Can we ignore some of them and keep processing? Should we wrap any errors that occur from the lower down the call stack in our own custom error and enrich it with data we know about? So let's take a step back and see how this code plays out. So I'll just deal with the errors in the calling code. Me, 6 months ago, probably. I go and I whip up a new page and component for our admin team. I'm kind of just moving fast, not really caring. I have a little bit of error handling, but as we see, I don't really actually handle my errors anywhere. And I say, I know this works safely for my use case. Catching all the errors with an error boundary is fine. It's just an internal tool. Also me, 6 months ago, probably. And then the new dev starts. I need a function to fetch a domain for the client dashboard. This looks useful. I'm sure it's safe to use. Import find domain for user from libdomains. Let's focus on that. I'm sure it's safe to use, and Dillon knew what he was doing. Well, turns out auth.check can fail in probably about half a dozen different ways. Pain. Also, db.queryDomain can fail in a variety of ways. Oops. And we actually threw our own error in here. This is fine. New dev gets his PR merged into main, it deploys. 10 minutes later, internal error, auth check failed for resource domains and action query. So what is the root cause here? At least in my opinion, it's unknown. Or more specifically, the fact that errors are typed as unknown in try-catch. If I could get down on my hands and knees and beg the TypeScript team to implement one feature, it would be the ability to annotate that a function throws and able to use that annotation to infer types for our error catches. But unfortunately, that is not the world we live in. So let's look at an example here. So let's say we have this sync DNS zone records. We take a DNS zone, and we're going to return just all the DNS records for that zone. And this function can throw 3 different specific kinds of errors that are enriched with data along the way. So it can throw a DNS propagation delay error, a DNS zone not found error, and an invalid DNS zone error. When we go to wire this up in our component on the front end, we throw it into an action, start our transition, call our function, get our records back, set it into state, clear our error, and then we set an error if we get it. But we just lost all of that semantic meaning from our errors that we encoded into the previous function. We had crystal clear context that we could provide to our users, to logging, to telemetry, and we just lose it here, all that work. And 9 times out of 10 in this case, you're going to end up just using a generic error message if you even wrap this in try-catch at all. It might bubble up to a higher up error boundary that has an even more generic error message than this. So how do we get that context back? All that work we put into having really good errors with descriptive names that carry context and data with them. Well, prepare yourself. We're going to have to first set a base case message, and then we're going to check if it's an instance of error. Then we're going to check if we have an instance of the DNS zone not found error. Then we'll update our error message, but we also have to check for our other instances. We'll update the error message there. Then we have to check for the other instance of. We'll update the error message again. Finally, we'll set it into state. Whew. So a high degree of discipline is required to scale TypeScript, especially in large engineering organizations, and especially if you're working with many teams in large monorepos. And unfortunately, discipline does not scale on its own. I've had the privilege and opportunity in my career to work in many, many different engineering orgs through my time consulting at Formidable, shout out Ken, and getting to work at Vercel with some of the most talented TypeScript developers in the world, and this is a problem everywhere, regardless of the skill level of the engineers at your company. So next, I want to talk about a case study at Vercel, and I want to talk about the power an error can provide you, your users, and your application. So earlier this year, my team shipped self-serve domain renewals. Up until this point, Vercel only supported auto renewals. So if you wanted your domain to renew, you would have a toggle, flick it on, flick it off, and at the year point, it would auto renew for you. The domains product area had the second highest amount of customer support tickets month over month, with the majority resulting from renewal issues. And in our cron job that ran renewals, we had 3 typed errors. We had an API error, which is hilarious because it wasn't an HTTP service. We have a Stripe payment error and a Stripe payment method error. So we took the opportunity as we were pulling out the renewal logic to put into our next application in the client dashboard. We audited our errors and introduced never throw and tagged errors. We'll talk about never throw a little bit later, but I want to cover what a tagged error is here quickly. So a tagged error is basically just a literal tag or a discriminator you can put on an error. It's, in the implementation, you would see that like underscore tag as const the string name. This makes it so much easier to effectively like pattern match on errors, so you don't have to do that whole instance of thing over and over and over. You can build nice utility functions around it. Just a nice little trick I like using. So this resulted in a dramatic reduction in CSE tickets, customer empowerment, and improved the time to fix issues and bugs thanks to improved telemetry, error logging, and observability. And in the end, we ended up with 17 distinct error types, each with its own context, user-facing error messages if it can get out to the client, internal messages to help us with debugging, their own constraints, and retry characteristics. Maybe a handful of these errors in this list we can just treat as a warning and move on. Maybe in some cases we need to refund an invoice, or maybe some cases we actually have to effectively like panic and go back out to the caller and say something bad has happened and reach out to customer support, right? The reality of our software is that it is incredibly error prone. And because of TypeScript enabling us to just put on blinders and look at the happy path, we have a tendency to easily neglect errors like this. So one thing I truly, truly love, and getting granular on errors like that last slide enables error messages like this. So Wix Engineering put out a blog post a couple years ago now, and they described what is in a good error. Say what happened, provide reassurance, say why it happened, help them fix it, and then give them a way out. If you are treating errors generically, or just have a small couple of strings that you're setting in state, you cannot provide this kind of experience to your users, and you're gonna have nightmare situations when you're getting paged at 2 in the morning by PagerDuty trying to figure out what's going on. So let's talk about the result type. So the result type is effectively a type that has 2 generic parameters, the OK type and the error type. If it succeeds, we'll end up with the OK type. If it fails, we'll end up with the error type. And in its simplest form, it can be thought of as a simple discriminated union with 2 variants. The first variant is the OK variant. We have a tag to discriminate it or help TypeScript narrow down the type, right? We can do like, if tag equals OK, then TypeScript will know there's a value. And then the other one is the error. In its more featureful implementations, you will generally find some sort of interface that looks like this, right? We're going to have a bunch of functions for working with results rather than just having these plain JavaScript objects. So we'll step through this in a second. So the first is map. This is going to be super similar to array.map. We're going to give a callback. It's going to give us the internal value. We can apply a transformation to the internal value, and we get a new result out. That ends up looking like this. Say we have a result number error. We want to transform it to a string. We just say result.map, pass our function in to convert it to a string, and we end up with a result string error. The next is and then. And you might see this by a couple different names. You might see it as flat map or bind. Never call it then because of JavaScript's thenable interface. You just don't do it. I promise there's a world of pain there. So chain, or and then, is like the older brother to map. When you use and then, the callback function you pass in needs to return a new result. This lets us chain and compose errors together over time. So here you can see we have this only positive. We pass a callback. If it's greater than 0, we return an OK result. And if it's not, we say error non-positive. And we end up with a result that is number as the OK variant, or non-positive, or error. You can see how kind of it composed and tracked the errors there. The next is unwrap and unwrap or. These are ways to kind of get the value out quick and easy. So let's say we just have this failed result and we call unwrap. This will cause the result to throw. Really only recommend this in testing. And the other one is unwrap or, where you can give it a default value if you have the error case. And the final one is tap. And I forgot to include tap error on here, but it is a way to run side effects in your kind of chain with your result. So you can see here we tap the success. Maybe we want to annotate our current span with the success value, or we want to tap error and get the error value and annotate the span as well. So one implementation I really, really like, it's basically a port of Rust result type to TypeScript, is never throw. I'm going to be using never throw for the rest of this presentation. Highly recommend checking it out. So what are the benefits of the result type? Well, we get crystal clear guarantees of how our code will run at a glance. If the computation succeeds, we'll end up with the OK type. If it fails, we'll end up with the error type. And if we were to zoom in here on parse TLD, right, and this is a function that returns a result. If we were to open up our hover docs in VS Code or Neovim, we would see a type definition that looks like this. Parse TLD is a function that takes a string and returns a result that if it succeeds, we get a TLD, and if it fails, we get a parse TLD error. So unlike the functions we were looking at earlier, we can immediately see in the code we're writing, just by looking at a type documentation, how a function is going to operate, how it will succeed and how it will fail. There's also no hidden control flow, right? With try catch, what that essentially means is when an error is thrown, it's going to bubble up the call stack until there is a catch, and there's no way of knowing what's going to happen or when that will happen. In our case, let's say we look at the implementation of parse TLD, right? In each of the places where something can go wrong in our function, we explicitly return an error. Or at the end, if everything has succeeded, we've returned OK. Crystal clear to see how this is going to work. So most importantly, the result type is composable. We can chain computations together that may fail with static guarantees that will gracefully handle the unhappy path, right? So let's think about like a simple example or a small example of renewing a domain. Let's say we have a query domain function that will go and get our domain from the database, and that can fail with a domain not found error. And then we need to enrich that domain. We get back an enriched domain. And then to finally renew, we pass an enriched domain to renew domain, and we'll get a renewed domain out. Now, all the errors that can happen there, 3 of them, right? Domain not found, enrichment error, and renewal failure. If we look at what this looks like in implementation, right? One thing to narrow in here is if any one of these functions fails along the way, the others will no op. So if query domain fails, it'll essentially immediately return from the current scope with the error that it returns. We've seen this a bit already, how errors are going to get unioned together as you chain computations on a result type. But if we were to take away the type annotation there, right? Right now it's annotated as an async result that returns a renewed domain or a renewed domain error. If we let TypeScript infer this, you're going to end up with a type definition that looks something like this. It's going to return a promise that has a result of renew domain, and then we're going to have 3 errors. The type system knew that it can union those errors together, so you can just write your code and rely on the type system to track errors for you. Treating errors as values with the result type, whether with an implementation like never throw or a simple discriminated union, will make your code safer, more resilient, and predictable. So to quickly get us out of here to our break, we're going to have a quick practical guide to how to use this with React a little bit more concretely. So a couple tips. Wrap unsafe code. In a lot of result libraries that you might install from NPM, they're going to have some sort of like try function and try promise function where if you don't know if a function will throw, or it might be a third-party package and you don't want to dig into like the full implementation, just wrap it in try. And what this is going to do is effectively, if that function throws, it will automatically wrap it in a result for you. So if it succeeds, you get the OK value. If it fails, you can wrap it in a custom error right on the spot. Same for try promise. Another important thing is leveraging I/O boundaries and runtime type checking. So using something like standard schema, Zod, archetype, effect schema, validbot, whatever it is, anytime you're doing I/O, whether that's in like a server action, reading something from disk, going to the database, calling out to a third-party API, when that data comes back, validate it and parse it, and then take the result of that and put it into a result type. That way you know at the very outer boundaries of your application, the whole way down through, that you can operate safely on that data. Next, reserve error boundaries for defects. And a quick word on defects. There are two kinds of errors. Those that we can expect, program defensively against, and analyze statically. And those that are truly exceptional and outside of our control. So a defect might look like a data center going down and we can't actually make a call to a service. Or maybe our user loses internet connection while they're using our app and they get a timeout. Those are truly exceptional circumstances where defects happen. Reserve your error boundaries for that and get granular in managing your errors inside your components. In a similar vein, be specific with your error types and enrich them with data and context. So as you encounter errors, extend the error class and put fields on there that are relevant, that will help you debug, that will help you present useful error messages to your users. So in this example, right, like we have the TLD badge component, right? We can match on the tag of the result.error. And if we have an invalid domain type, we can pull out the domain name that we've been tracking, or the TLD in the domain name. And if you're using use SWR or TanStack query, be incredibly cautious about the generic error type. It is, unfortunately, pretty unsafe to provide a value here and treat it as anything other than unknown. You can do it, but you will create a false sense of safety for yourself because that is not enforced anywhere else down the stack. So what I like to do with use query or TanStack query or use SWR is effectively treat the error as a defect, unknown circumstances that bubble up there, and then return a result type into the data channel, or the data value, excuse me. So if you've never written code like this, it will feel tedious and verbose and foreign. My best advice is just stick with it. Your users, coworkers, and future self will thank you. So, in summary, treat errors as values, whether it's with a result type or simply returning errors from your functions. Embrace the unhappy path. Leverage the result type. Build better software and products. And ultimately, throw try-catch in the bin. Thank you, Miami.